So far, with our previous video, I have been showing you about maybe less than 5% what you can do with regular expressions. However, in this video, what I'm gonna do, I'm gonna show you how Perl construct the use of regular expression. So first, what I would like to talk about is the syntax. Note that it is not terribly exciting to talk about the syntax, but this will give us some ground on how Perl thinks about the matching. So the use of /foo/ from the first example we saw at the beginning is nothing more than saying m/foo/. So, but m can take another delimiter, so very similar to what we learned in the quoted word, that we can use any type of delimiters, either paired delimiters or non-paired delimiters. So here, for example, m open parenthesis hello close parenthesis also will match as we saw with the open parenthesis foo open parenthesis. The other one, if I want to use one of the options using the bar, here I am using the square bracket, so m open square bracket Fred or Barney close square bracket. Also, I can use, as I said, any delimiters non-paired. For example, here the exclamation mark. So preceding with letter M, then exclamation mark, Perl will know that you are doing regular expressions. Don't forget, you have to end it with exclamation mark as well. So here is searching for the word this. Now, you have to remember, balanced delimiter nested properly. You have to nest them the right way. Here, for example, I have the regular expression m open parenthesis Fred space, and I am saying either and or close parenthesis space Barney and close parenthesis. So here I'm saying I want to match the regular expressions Fred space and an or space Barney. Otherwise, if I am not using the exact interpretation of the delimiters, I can use always a backslash. Like here, m question mark foo. Here I have backslash question mark bar question mark. So the one in the middle, since I have a slash before it, it knows this will be interpreted as it is question mark. Now this is a stupid thing to do, to use the delimiter as well as using it inside the expression. So I will avoid it. I will use something different, parenthesis or a curly bracket or squared bracket. Now the last one shows the importance where you can use the m delimiters, the alternative delimiters, instead of the slash. Even though the slash is easier, you are consuming less one character, which is the m. So here, for example, if I want to match the http : / it's some kind of ugly way of looking at, like http : then I'm saying okay, I'm gonna use the exact delimiter slash, so I have slash, then backslash, then slash, and backslash, and then slash. So the second sentence make it more easier and look nicer. Curly bracket http : / I don't have to really use delimiters, and then curly bracket. So explicitly I'm gonna do a match with http : //. Okay, now what else? Let us talk about modifiers. Normally matching is case sensitive. So let us say I am asking for a lowercase. So this case I have to match a lowercase in a string and so on. But also you can have it insensitive by using the letter I. So here I am adding after the regular expression the letter I. Perl will know exactly that here you don't care about the case sensitive. So even if you entered yes as a capital, uppercase, all of it, part of it, or lowercase, will know exactly that this is matches and case sensitive is not case sensitive, case insensitive. So what else? We know that we can match the new line with the period. In this case, to be able to do this, we remember that the dot, it matches any character except the new line. So if I want to combine both, here I'm saying Barney dot star Fred and then slash s. S, what we'll do, will apply on the dot the concept that now the dot is not any character but also the new characters included. So here we'll match Barney new character Fred, or Barney whatever it is, the word hello world, for example, Fred, whatever characters in the middle. So we are combining them. Now, how about combining both case sensitive, case insensitive, and the new line? So here, on any character, you add at the end is or si. So the order is not important in Spanish or in English. So si or yes or is. Okay, let us move forward. Another thing we can do with modifiers that make regular expression just easier to read. So this is only for reading convention. The X at the end of the regular expression modify the look of the regular expression. Actually, what it says that internally the white spaces in the regular expression is almost any place that is just ignored. So any place I have, for example, enter, tab, one space, multiple spaces, will be ignored completely, will be not part of the regular expressions that I am using. To do that, you add the X at the end of your regular expression. So as I said, so spaces or tab no longer match themselves in this way. Now, what else? You can also use the backslash s plus, which makes make sure to follow with X, and otherwise whatever will never be matched. So in this case, if I separate my second line expression into a couple of lines, this is exactly the same like the second expression, but I was using tab and then slash, either or, the dash is included, then the digitals, some digits, then optional period, then optional digits I'm saying, and then closing it with X. So if I forget the X, actually all this expression will be matched, and tab will have to be matched to be able to get the right matches. Not only that, what I'm putting there as comments, the pound optional prefix, as you remember the comment in Perl was start by pound. Here, if I don't put the X, will not be interpreted as a comment, will be part of the regular expression that you are mapping to. So just to remember, even with putting the X, not only will understand the spaces, also will understand the comment as a comment and will ignore them from the regular expression. So what else? Anchors. This is a very important part of the regular expression. We have a better way to write regular expression. That means that we can, for example, use some specific type of anchors. So the absence of anchors, regular expressions will flow from the left to right. So if I have the word, for example, love, and I want to search for the word love in a string, what does Perl actually will go from the beginning of the string, keep looking for the word love all the way to the end of the string. So if it doesn't find it, you're looking in the wrong place for love. So technically, if you want to control where Perl should look for the regular expression, you can do this with the caret anchor, which is the up arrow. So in front of the word that you would like to match, if you put the up arrow, that means I want to match Fred at the beginning of the string, only at the beginning. So if Fred appears in any other place in the string, I will not accept it as a right match, only at the beginning of the string. Now how about I want it at the end specifically of the string? In this case, I will have to put the dollar anchor at the end of my regular expression. As I said here, slash Fred $, so only match at the end. How about if I want to match exactly the word of Fred? In this case, I am saying at the beginning I am putting the up arrow, and at the end I am putting the $, and the word that I would like to match. So here if I have Fred will not match. I only have to have Fred exactly as a string, nothing more or less. Now, it is a very common mistake that some students do when they put the following match. If it includes only the digits allowed in the string, what will happen here actually, that will allow any digits but also the string. So foo 34 bar will be a match because I didn't specify at the beginning, at the end, the length of the place or the location of the digits. There is a better way that you can fail, for example, saying any digit, any characters but digits, which is with the capital D. On the right side you have a complete example. While I am reading from the keyboard, how about finding all the non-digit characters from 1 to as much as I want, and this is followed exactly with the end of the line. Like I only have that specific string of non-character, which would be digit, starting by a digit and ending by a digit. So I'm restricting the search. In this case, I am searching. Sorry, here I'm searching for characters, so I'll print characters. Now, if I am searching for specific digits that start with a digit and end with a digit, will print for me digits. Otherwise, we'll print a mix. Anything else I am putting there will be printed. So let us try this example. So you can understand what I'm talking about. So here, if I put KKK, character only, if I say, and it print a mix also. 0, 0, I have to make it different way because I'm printing both. Now if I'm printing this, will only print a mix. So I have to make some corrections. Maybe I will put else. So character, so it went also to D because it didn't match the first one. Okay, so what we can say here, we can do the following. So the print, so I made some changes here. Let's say if it's only non-digit, specifically character only, starting and ending with character, will print characters only. Else, if it's checking again, if it's only digits, will print digits only. Otherwise, will print the mix. And this way, will not get the two statements. So here, I print character, will say character only. I write digits, will print digits only. If I write strings and digits, will say mix. If I say digits and character, will say a mix. So that's it. Very simple. So after the anchors, we have to talk about word boundaries. The concept here is a little bit different because here we are matching the edges as if there is an edge at the end of a word. So the matches of the edges is either at the beginning or the end of a word. So suppose I have /b, phrase /b. That means at the beginning of a phrase and the end of the phrase, it is better not to be a character. It will match Fred, but it wouldn't match Frederick, for example, because the D is not on the word boundary. Okay? And it wouldn't match, for example, Manfred, because it is not on the word boundary. Okay? The beginning of the word is not F. So we can consider /b, it is everything contiguous to \w plus, which is any word. In other words, anything that is alphanumerical and underscore. For example, in that is a word boundary ! The words are beginning and end of the word, so that, beginning at the end of the word S, beginning and the end of the word A, beginning and the end of the word, and beginning and the end of the word boundary. So /b will be match actually in 10 places from the beginning of the word and the end of the word. So note that /b doesn't consume any character. It represents an edge. It's like when we use the upper arrow. It represents the beginning of the string. So what is really we have here, it really bugs me that it is considered, if I say /b can /b and slash, that it match not only can but will match can't. So that's really, what I am expecting to match. If I want just can in this way, I cannot. Can't will be considered a match as well. Also, there is available the word, not word boundary, anything else beside word, which is the \B. Okay, so this is the inverse for each word. Now, how about the binding operator? So everything we have seen has been against the $_ so everything was saved in the $_. It is convenient if the string happens to be there, so Perl use it because it's available. And often where you do the while with reading from the standard input-output, you know that this is where the place that you save your variables. But if you want to match with something is not in the $_, no fear. So we have to use the bind operator. The name is a little bit weird, I know. So the way that it's gonna work with the operator equal and tilde. This is not an equal sign, and I'm gonna talk in details about it just now. Like here, I have a line, like the first line, I am searching, the third line, I am reading from the input-output, the keyboard of course, and I am assigning whatever I am reading, not to the $_, but in a scalar named some other. Now what I'm doing, I am matching whatever is in the some others that I read from the keyboard with the word rubble. So in that case, Perl will evaluate in a scalar context as a string. That string will be used against the regular expression. So here I have taken the line operator. I am reading a line from the standard input again and put the value in $, some other. And then we are saying if the dollar sign some other is equal to ruble, that means that what I read from the keyboard is already entered and contain the word ruble. If it does, that whole things return true. Even that you have an equal sign here with equal tilde, this is not an assignment at all. We are not going to assign value. What we are trying to do here, or even altering any other type of force, it is merely looking at it. So it is merely saying, look at this over there in the place of dollar sign underscore, and don't involve the dollar score underscore at all, but put the whole things inside dollar sign some others and see if it has the word ruble, and return the value true or false. Does that match? Will return true. Doesn't match? Will return false. So the expression, this is what it's doing, nothing more or less. Now, the interpolating of patterns. We said so far that regular expressions process everything, including double-quoted strings. One of the other things double-quoted do, beside the \n and \t, is also allow you to include variables, as you remember in the print statement. So let us take this little piece of code. I put Larry in $what. I have a diamond loop, so I'm reading from the input line from the keyboard. So I am reading one line at a time, and put the input in $underscore. This is very important. So then I'm saying stop when I hit the exit, or the Command D in Mac, or Control Z in Windows. Then in the third line, that is interesting here, Perl says, oh, I have a regular expression. This regular expressions contains variable reference, in this case $what. Perl will take this current content and of whatever it is in $what and insert it there directly in the regular expression. In this case, it will act as if I have typed upper arrow Larry. Okay, so close parents. Then it takes the content and match with the current $underscore. And of course, this is will return true or false value. If Larry at the beginning of a string that has been read in $underscore will say we saw Larry in the beginning of $underscore, whatever the line actually has there, you wrote there. The value Larry becomes part of the regular expression. It works every time you enter a new line. So as you notice, the $what is compared and in runtime, so you notice that this is very important. You don't know really what kind of input you have. So, but how about if I change the $what to my $what equals shift? Here, what it happened that Perl will understand that I'm gonna take the first parameter that comes from the command line that the person's gonna enter and put that specific as our regular expression, and will remain the remaining parameters are going to be the file name to read. This is very close to what grep does in Unix. We managed to do that in Perl only with these 5 lines of code. So we take the regular expression, then we read the rest of the line using the diamond walking all our way through. The only modification, by the way, that I have up arrow anchor at the beginning. That is the only thing that makes a difference with what grep in Unix does. So that's it. Let us try this code. So now what I have in what is Larry, and I'm comparing whatever I am entering. If I am entering Larry, would say I saw Larry at the beginning. If I say Larry is here, so we'll say we saw Larry in the beginning of Larry is here, because I am printing whatever is in $_, which is what I wrote, Larry is here. How about I am putting Larry in the middle? As you can see, it doesn't work. Now how about using this shift operator? So here I am saying it's gonna contain whatever I have at the beginning. So let's say Lily. It knows that this is Lily. We saw in the beginning Lily. So we'll just grab whatever I put as a beginning of inside the shift, and we'll compare it with it. Okay, let us continue. Now how about matching the variables? This is another way that we deal with back references. So as we saw earlier, the parentheses in regular expressions trigger back reference 1 and back reference 2, back reference 3. We don't use it in this way so often, but I just would like to mention for you because it's very popular in creating puzzles, puzzle words, and many type of games kind of Perl expressions. So here what we have in our regular expressions, the parentheses. The regular expression then correspond to the value that will be into one of the memory variables, which is named back reference variable. So actually \1 in the regular expression is the first back reference, will actually map to the variable $1, which is available for us to be used by Perl. So the first I will start with in the phrase hello there, comma neighbor, hello there neighbors, we'll put in the $_ underscore the strings hello there, comma neighbor. Then I have a regular expression that says \s parentheses \w plus close parentheses comma backslash or slash. So what we are doing here, looking for a single white character, okay, and then I am looking to one or more word character in alphanumerical or underscore. The third I am looking for a comma. So where this exists in this string? Actually it exists in the middle, which is there. So in this case the word there will be saved inside the $1 automatically, and if I print it, will say the word was there. This is very important because you might think, okay, here I am matching white space with word, so the comma could be considered part of the word, and Perl first might get the comma including with there, but then it sees that there is a comma after that, so we'll leave the comma to match exactly with that expression. The other one, which is very common, is the second one, if slash parenthesis \, capital S plus close parenthesis space open parenthesis \S plus S capital and then close parenthesis comma space open parenthesis \S plus close parenthesis. What I'm doing here, I'm saying give me the first match in the same string up there, the hello there neighbor, and find me the words continuous non-spaces words, and there we'll match the first one, the word hello, and put it inside the parentheses, the first parenthesis. And here I can call the variable $1 and bring this word, which is hello. Then a space, we'll match the space, then another word, which is the there, so we'll put the there inside the variable $2. Then I have a comma, we'll match the comma, space will match the space, the third word neighbor will be in the third place, which will be saved in $3. So when I print this sentence, we'll be able to print it all for me. So let us try it again. Of course, I will remove what is not needed, if there is any. So here, as you can see, the first one will match and the second one will match. So let us try it. So as you can see there, the word was there, so it brings the one there, and the second one, words were hello there neighbor. Okay, so the hello from the variable 1, there from the variable 2, and neighbor from the variable 3. It's good habit to go and test whenever you can test. Now you have to remember that always to test what is the match is by using the if statement, because the match will be into the memory as long as you are using the regular expressions. And always this will allow you to know if your match is successful or not. So it's a good habit not just to put the regular expression without the if statement. Now, what else? Non-capturing parentheses. When I am using parentheses for precedence, it also triggers memory. So when I say if parentheses slash open parentheses backslash s plus close parentheses space open parentheses and or close parentheses space parentheses backslash s plus close parentheses, I have to remember to use $1 and $3 because the middle one also is triggered. Unless if you want to avoid that and not to use it for the option here and or, you can use the question mark colon. So here, as you can see, in the line 1, 2, 3, 4, 5, 6, we substitute the beginning of the end with question mark colon. So in this way, we will not be using the second variable space. So we can check it with $1, $2. The first expression of the parentheses backslash s plus close parentheses will be in the variable 1. The second one will be ignored because we put the question mark colon. The third one, backslash s plus close parentheses, will go into the variable 2. Now, actually in Perl 5.10 they introduced what is named name capture. So this is more extension even to use a specific mapped hash variables if you want, and it goes in this way. So it maps the variables that we talked about in the memory 1, 2, 3 into your code, so you can use them over and over, or using that doesn't have to be in the order as we saw previously. So here the name of this hash table is plus, so $sign of plus, and as you can see the curly bracket, this is how we knew this is a hash. And the name here, I named it name. So if, this is how you call it, if slash open parentheses question mark less than name1 greater than backslash s plus, then in the middle I put and or, and then I use another variable name2. So here we'll map the first one to name1 and the second one to name2, and you can call them to print them out. And it doesn't have to be in order when you print. It's not like that you are stuck to the order. Now, what else? You can consider any operations that you do matching. Really, it has 3 parts. Part before the match, part that it match, and part after the match. Perl has a specific characters that you can bring them to find the matches and the parts before and after the matches, and they have specific characters. For example, $ampersand, it is a match, where $, open quote, is before the match, $, single quote, is after the match. So here, for example, I have a regular expression says either Fred or Barney, and my text says I saw Barney was afraid. So here the first match I will have is Barney. I'm saying one of them. So anything before that I saw will be inside $, open quote, which is the one that on your keyboard on top of the tab. So inside it I will have I saw. Barney will be inside $, ampersand, with Fred today exclamation mark will be in $, single quote. So if I print those, we'll have the exact sentences I just mentioned. Okay, what else? We saw the quantifiers, the star and the plus. There is a more generalized way to use those to make them more specific. So here, for example, I am saying I want specifically the letter A to be repeated from 5 to 15, specifically, either 5, 6, 7 to 15. So it will be A to 15. Now, always I have lower bound and upper bound. Now if I use a single number, here I'm saying I want exactly that many. So here I'm saying I want exactly 7 C's as a match. Here I'm saying I want exactly 5 comma then the word Chamelon. Now single number followed by comma, that many or more. So this is very nice one. So here I'm saying I want Fred, and I'm saying 3 times repeated, comma, it means or more. So here I have to use it completely, curly bracket, curly braces, 3 comma, close curly braces. So here we'll use Fred, 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 or Fred, 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 Fred. You got the picture. Now you can substitute, as you can see, the star with 0 or more. So this is how it's equivalent to the star, or 1 or more will be equivalent to the plus, or will be 0 or 1 will be equivalent to the question mark. However, don't use it because it will look funny. Now this is the last slide in this video. You have to remember there is precedence in the regular expressions. As we have in any math operation, the parenthesis is the highest, and etc. So it is the same here. The parentheses are the highest. For grouping, for back references, it takes the highest order. After that, the quantifiers comes, then the anchors and sequence, then the alternation, then the work on the single character. So, for example, if I wanna see the difference between those two sentences, here I am saying I want either a string that start with afraid or a string that end with Barney will work. Where here I'm saying I'm gonna pick either afraid or Barney, but this is the exact match, nothing more. So a string that contain Fred or a string that contain Barney. But if I have Fred hello will not be a match, hello Barney will not be a match. It should be exactly one of those two strings. So this is a big difference between both of them. So we'll have another video for regular expressions, and then we'll be done completely.